Ever wonder how your AI assistant just knows what to do? How it manages to be helpful but also, not harmful? Well, today, we're pulling back the curtain on a truly landmark paper from the research group Anthropic. It's the paper that basically laid the foundation for the helpful, harmless AI assistants we all use now. And it all started with a really simple idea that honestly changed the entire game.
All right, so let's just get right to the heart of it. The big question. How on earth do you teach a computer the difference between right and wrong? I mean, it's not like you can just program a list of rules, right? Our values are messy, they're complicated, sometimes they even contradict each other. This is the absolute core challenge of what we call AI alignment. And it's exactly what this research set out to solve.
So you got to understand the context here. Before this paper came along, the AI world had a huge problem. We were building these super powerful language models. I mean, these things could write amazing poetry, summarize dense articles, even code for you. But, and this is a big but, they were completely raw, totally unpredictable. One minute they'd give you a brilliant insight, and the next they could spit out something toxic, biased, or just dangerously wrong.
And this right here, this shows you exactly what I'm talking about. On one side, you have the raw AI. You ask it how to rob a bank, and it might actually start giving you pointers. Yikes! On the other side is the goal, an aligned AI that gets what you're asking, understands it's harmful, and says, nope, can't help with that. The whole challenge was, how do we get from point A to point B? How do we make that happen reliably every single time?
So what was the solution? Well, what the researchers came up with was, honestly, it was brilliant, super elegant. Instead of trying to sit down and write some massive, complex ethical rulebook for the AI, they thought, what if we just let the AI learn from us, directly from our own judgment? The whole idea was basically to show the AI what we prefer instead of trying to tell it. And this technique has a name you've probably heard: reinforcement learning from human feedback, or RLHF. It's this clever, multi-step process that takes something as fuzzy as human intuition, that gut feeling about what's a good or bad answer, and turns it into a mathematical signal that an AI can actually learn from. This right here became the foundational method for aligning AI assistants. Okay, but what does that actually look like? How does this whole human feedback loop work in the real world? It wasn't magic, believe me. It's a super carefully designed, step-by-step process that builds up into a whole training pipeline. The whole thing really breaks down into 3 main stages. First, you get a bunch of people to create a massive data set of what they like and don't like. Second, you use all that data to train a totally separate model, which you can think of as a preference model. Its whole job is to predict what a human would prefer. And finally, you use that model, that AI judge, as a guide to fine-tune your original AI. You're basically training the AI to get a high score from the judge. And check this out. This is so cool. This is literally what it looked like. This is the interface that human labelers or crowd workers were using. So they'd be having a chat with an AI, and for the AI's response, it would generate 2 different versions, A and B. The person's only job? Just pick the one that's better. Which one is more helpful? Which one is more honest? They did this thousands and thousands of times, and that's how they built this incredibly rich data set of human preferences. All that data then gets fed into training that preference model we talked about. And the best way to think about it, really, is as an AI judge. This judge has seen countless examples of human choices, so it starts to develop its own intuition, its own taste for what we humans think is a good answer. It can then look at any brand new response from an AI and give it a score based on how likely it thinks a human would be to approve. That score is the magic ingredient. It becomes the reward in the reinforcement learning stage. So, the big question is, did it work? Oh yeah, it absolutely worked. But the results were actually even better than anyone had hoped for. It led to this completely surprising discovery that kind of turned a long-held fear in the AI community completely on its head. Okay, so first things first, the main result was a huge success. I mean, a resounding success. When they put the models head-to-head, human testers overwhelmingly preferred the answers from the new models trained with RLHF. They were rated as way more helpful and way less harmful. So, yep, the basic technique worked like a charm.
But here's the thing. For years, a lot of people in AI were worried about something they called the alignment tax. The basic idea was that making an AI safer had to be a trade-off. To make it harmless, you'd have to kind of cripple it, right? You'd make it less capable, less creative, less useful. The thinking was that safety always came at the cost of performance.
And this is where things got really mind-blowing.
The paper found that, okay, for smaller models, that alignment tax was real. They did take a performance hit. But for the biggest models, the ones with billions of parameters, there was no tax. In fact, it was the opposite. As you can see from the data, RLHF training actually improved their performance on all sorts of standard tests. They called it the alignment bonus. The AI got safer and it got smarter. A total win-win.
So this discovery, this alignment bonus, paired with just how effective RLHF proved to be, well, it kicked off a whole new era for AI. The methods laid out in this one paper quickly became the industry standard. This is how we build the AI assistants that millions of us are talking to every single day. And, the researchers themselves put it perfectly in the paper. They wrote, there's little reason to deploy models that have not been fine-tuned for alignment. I mean, think about that. The benefits for both safety and performance were so obvious that just putting a raw, unpredictable model out into the world was no longer seen as responsible or even competitive. This paper just set a completely new bar for what a real-world AI system should be.
And that leaves us with a really critical question as we move forward. This whole technique proves that an AI's values are a direct reflection of the human values it's trained on. But think about it. This paper used a specific group of people, crowd workers, to provide that feedback. So it makes you wonder, whose feedback gets to define what helpful and harmless really mean for everyone? As this tech gets woven deeper and deeper into our lives, that's a question we all need to start thinking about.
This is for entertainment purposes only.